Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera bagi kita semua. Om Swastiastu. Good afternoon, ladies and gentlemen. Welcome to Bincang Bahari, Web Seminar Series 7, Institute for Marine Research and Observation. The topic of this seminar is Ocean Observation and Modeling to Support Marine Resources Management. This webinar also live from our YouTube channel at Bepol KKP. And all of you also can stay connected with us to our social media, Instagram and Facebook at Bepol KKP and also Twitter at @riset_Pencak. Before we start this webinar, let's pray and gratitude to Allah Subhanahu wa Ta'ala. Because of His blessing and grace, we can join virtually on this event. Ladies and gentlemen, now I would like to welcoming the Excellency Professor Insinyur Raden Syarif Wijaya, PhD Afrina, Head of Agency for Marine and Fisheries Research and Human Resources, Ministry of Marine Affairs and Fisheries. Good afternoon, Prof. Syarif. Good afternoon, Prof. Syarif.
Thank you to all of you. Thank you.
Now, the Honorable Dr. Inyoman Radiarta, MSc, Head of Marine Research Center. Good afternoon, Dr. Nyoman.
Good afternoon, Wulan. Thank you.
Well, in this webinar, we have 3 special speakers, and now I would like to welcome our first speakers, Asmi Napitu, PhD. She is researcher of Institute for Marine Research Institute and Observation. Good afternoon, Mrs. Asmi.
Hi, Wulan. Good afternoon.
How are you today, Mrs.?
I'm good.
And just information, Mrs. Asmi now is in New York, right?
New York is not that safe right now, so I moved to Washington in Seattle. So
all right.
It's almost midnight right now.
Evening in there, Mrs. Asmi?
Yeah, it's almost midnight here, but I have a lot of coffee, so I'm good.
Okay, thank you. And the second speaker is Dr. Wezesud. He is from First Institute of Oceanography, Ministry of Natural Resources, the People's Republic of China. Good afternoon, Dr. Wei. Good afternoon, Dr. Wei. Okay, well, we move to the third speaker, Dr. Dwi Yoga Nugroho. He is researcher of Marine Research Center. Good afternoon, Dr. Dwi Yoga.
Hello, good afternoon.
Okay, thank you. And in this seminar, we also have a moderator. She is Dr. Desi Berlianti. She is researcher of Institute for Marine Research and Observation. Good afternoon, Dr. Desi. How are you? I'm good, thank you, Dr. Desi. Well, ladies and gentlemen, without further ado, now we will hear the opening speech from Head of Agency for Marine and Fisheries Research and Human Resources to Professor Insinyur Syarif Wijaya Afrina, PhD. Time is yours.
Well, thank you, Chairman. I would like to deliver my speech in Bahasa Indonesia. Some of the important phrases I will translate it into English. Ya. Selamat Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Om Swastiastu, Namo Buddhaya, Salam Kebajikan. Very good afternoon in here in Indonesia. Dr. Si Xun Wei and other researcher from our partners all over the world. Selamat siang, Dr. Inyoman Radiarta, Kepala Pusat Riset Tautan, Dr. Desi Berlianti, peneliti dari Balai Research Observasi Laut, kemudian juga Dr. Asmi Marintan Napitu, peneliti dari BROL, yang saat ini sedang dalam posisi malam hari di sana ya. Mudah-mudahan Ibu tidak cukup kopinya sehingga tidak mengantuk di malam hari. Yang saya hormati Dr. Dwi Yoga Nugroho, ya, dari Pusat Riset Kelautan, rekan-rekan para peneliti, hadirin sekalian yang saya muliakan. Pertama-tama, marilah kita panjatkan puji syukur kehadirat Allah Subhanahu wa taala, Tuhan Yang Maha Esa, bahwa kita senantiasa dikaruniai nikmat sehat, nikmat kesempatan, sehingga di tengah pandemi COVID-19 ini kita tetap dilindungi oleh Allah Subhanahu wa taala, Tuhan Yang Maha Esa. Kita masih diberi kesehatan, diberi kesempatan untuk berkarya, diberi kesempatan untuk bermanfaat bagi nusa dan bangsa. Tentu saja harapan kami untuk semua peneliti, kita tetap pertahankan semangat kita agar apa yang kita hasilkan nanti bisa dinikmati oleh masyarakat. Bapak Ibu sekalian saya hormati, seminar ini mengambil tema Ocean Observation and Modeling to Support Marine Resource Management. Jadi memang di dalam ilmu pengetahuan kita akan mulai dari persoalan pemahaman. Jadi manusia diberikan satu kapasitas intelektual yang luar biasa, sehingga dengan kapasitas intelektual yang dimiliki, maka dia akan mulai belajar memahami fenomena alam yang ada di sekitarnya, bagaimana karakteristiknya, dan sebagainya. Di dalam perkembangannya, tentu saja cara memahaminya berkembang, tumbuh. Tidak hanya melalui visual ya, ataupun panca indera yang kita miliki, tetapi juga sudah mulai dengan alat bantu. Nah, setelah kita memahami fenomena tadi, maka kita mulai memiliki bayangan. Kira-kira fenomena alam ini mana yang bisa kita manfaatkan untuk kesejahteraan manusia. Dan mana fenomena alam yang kira-kira berbahaya, yang harus kita hindari dan harus kita lakukan persiapan-persiapan, ya, sehingga manusia tidak menghadapi bencana yang terkait dengan alam. So I would like to emphasize that the science and technology started with the understanding of the natural phenomenon. Yeah, we are given by our gods the intellectual capacity to understand the natural phenomena and how to use these resources for the what you call it, the welfare of the people in the world, yeah, in our country, in the neighbor. Other thing is that we are try to avoid all the natural disasters coming to our livelihood. Yeah, by understanding this phenomena, then we can continue to develop our methodology to consistently understanding, consistently prevent and protect our nature, our environment, our livelihoods from the what we call it, maximum disaster from the nature. Jadi Bapak Ibu sekalian, jadi observasi ini sebetulnya adalah suatu bahasa yang menarik, ya, kalau saya boleh katakan menarik karena bermain dari kata mengetahui. Kemudian dia akan lebih mendalam, dia mengembangkan sebuah metodologi untuk observasi. Setelah dari metodologi, maka kita akan membuat modeling. Apa yang terjadi di fenomena alam tadi, kita sederhanakan, kita buat suatu miniatur, prototyping, untuk memahami salah satu karakteristik yang kita bisa tangkap, dan kita bisa buat permodelan di alam. Ocean karakteristik misalkan, ya, ocean dynamic. Nah, kalau kita bicara hydrodynamic model misalkan, maka kita misalkan mengetahui tentang gelombang saja dulu. Maka kita akan membuat modeling bagaimana cara mengetahui karakteristik gelombang dan apa dampaknya terhadap sebuah kehidupan manusia yang tinggal di sekitar pesisir pantai. Kemudian demikian juga yang lain-lain, arus dan seterusnya. Kemudian kita akan meningkat yang lebih kompleks lagi, interaksi antara arus, gelombang, angin dan sebagainya. Itu akan membuat sebuah interaksi dan akhirnya membuat suatu dynamic model yang sedikit lebih kompleks. Nah, karena meningkat tingkat kompleksitasnya, maka kita akhirnya membutuhkan tools, ya, membutuhkan tools modeling dari simulation, computing models, ya, computer modeling dan sebagainya. Itu adalah alatnya. Nah, setelah kita tahu semuanya, baru kita membuat suatu marine resource management. Kata keywordnya adalah itu. Marine resource management selalu berbasis pada sebuah hasil observasi. Baru kita mengetahui bagaimana cara mengelola lingkungan laut kita semuanya. Bapak Ibu sekalian yang saya hormati, saya rasa forum-forum ilmiah seperti ini saya menyambut gembira dan we start our modeling by observing the natural phenomena in certain characteristic, then try to move forward to the more complex models using the available tools like computing models and others, experimental design. So by understanding this natural phenomena and its relation between each characteristic, then we can promote our what we call it ocean resource management program. Get the maximum benefits from the nature. Jadi teman-teman sekalian, saya rasa saya menyambut baik inisiatif dari Badan Riset Observasi Laut ini dan semua para penelitinya. Tapi saya mengusulkan kepada Bapak Ibu sekalian, setelah kita mengetahui modeling seperti ini, mohon sesegera mungkin, saya ulangi, sesegera mungkin kita lekatkan pada apa yang menjadi persoalan kita. Misalkan kita bicara tentang tsunami. Sekarang kita mendapat isu misalkan di selatan Jawa, barat Sumatera akan ada potensial untuk tsunami yang cukup besar untuk Indonesia dalam waktu yang kita tidak bisa tentukan. Tentu saja dengan situasi seperti itu, maka kita harus mulai melakukan suatu preventive action, marine management untuk semua masyarakat yang tinggal di pesisir. Jadi intinya adalah hasil dari riset kita tidak boleh terlalu lama dalam bentuk level of know-how. Jadi tidak boleh terlalu lama di dalam hanya bentuk pengetahuan, tetapi sudah harus segera secepat mungkin kita transform menjadi sebuah plan of action untuk melakukan suatu preventif terhadap bencana maupun terhadap pemanfaatannya di masa yang akan datang. Saya rasa demikian teman-teman sekalian. Jadi nanti Pak Nyoman Radianta akan mengeksplor elaborasi lebih lanjut. Tetapi intinya kami dari Kementerian Kelautan dan Perikanan berharap semua hasil diskusi kita ini nanti akan berujung pada sebuah rekomendasi yang berupa plan of action yang bisa diikuti oleh masyarakat, ya, diikuti oleh semua stakeholder kita, sehingga kita akan menjadi sosok research institute yang akan menjadi panutan bagi masyarakat. Intinya sana, jadi tidak berhenti sampai know-how, tetapi kita harus sampai kepada kemanfaatan untuk masyarakat. Saya rasa demikian. Yang mengucapkan Bismillahirrahmanirrahim. Maka bincang-bincang bahari. Nah, ini kalau bincang-bincang bahari gini Pak Nyoman, mestinya harus ada kopi atau tea atau ada snack yang di depan kita. Sayangnya kalau kita memakai video call gini, tea kopinya nggak bisa dikirim ya. Mudah-mudahan nanti someday kita punya satu teknologi untuk bisa mengirim tea dan kopi ya ke anggota-anggota peserta ini. Saya rasa demikian. Terima kasih. Dengan mengucapkan Bismillahirrahmanirrahim. Maka bincang-bincang bahari webinar series 7 Ocean Observation and Modeling to Support Marine Resources Management secara resmi saya nyatakan dimulai. Terima kasih dan terima kasih sekali atas semua partisipasi para narasumber, para peserta. Semoga Tuhan menerima segala amal ibadah kita. Mas Yus, terima kasih. Ya, sampai ketemu. Assalamualaikum warahmatullahi wabarakatuh. Om Santi 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 Om, Namo Buddhaya, Salam Kebajikan. Tetap sehat, tetap semangat ya. Masih di mute, Mbak.
Wulan suaranya hilang. Suaranya belum kelihatan, belum muncul.
Ya, udah.
Ya.
Okay.
Now it's okay.
Thank you, Prof. Sarif, and thank you for the advice for the Bincang Bahari with tea and coffee. And now I would like to welcoming our Head of Institute for Marine Research and Observation, Dr. Teja Arif Wibawa, MSI. Good afternoon, Dr. Teja. Thank you for joining. And also it's already joining with us. The speaker is Dr. Wei Zesun from First Institute of Oceanography, Ministry of Natural Resources, the People Republic of China. Good afternoon, Dr. Wei.
Dr. Wei.
Ya.
Good afternoon.
Yeah, distinguished Rajat and Perja and Newman. It's my pleasure to take part in this seminar.
Thank you so much. Thank you.
Thank you.
I will show my
Thank you.
presentation.
Thank you, Dr. Wei.
Okay. Oh,
Yeah. Well, ladies and
I
gentlemen,
will share my screen. It's okay.
Okay. Well, ladies and gentlemen, before we start the main agenda, we will hear the speech from Dr. Inyoman Radiarta, Head of Marine Research Center. So, Dr. Nyoman, time is yours.
Thank you, Ulan. Suara saya bisa didengar nggak?
Ya, bisa Bapak.
Baik.
Silakan Bapak.
Baik, terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera buat kita semua. Om Swastiastu. Very good afternoon, Dr. Jason Wei. Yang terhormat Bapak Kepala Badan Riset dan Sumber Daya Manusia, Kelautan dan Perikanan, Bapak Profesor Dr. Insinyur Sarif Wijaya, PhD Frina, yang kami hormati Kepala Balai Riset dan Observasi Laut, Bapak Dr. Teja Arif Wibawa. I would like to extend a special welcome to our international speaker, Dr. Jason Wei from First Institute of Oceanography, Ministry of Natural Resources, China. And also a warm welcome to our speaker from Marine Research Center. This is the one scientist still loves to stay outside of Indonesia. Dr. Asmi Maritan Napitu, PhD. Actually, we are waiting for your coming to Indonesia. And of course, that's one researcher from a Marine Research Center, Dr. Dwi Yoga Nugroho. Serta bapak-bapak, ibu-ibu, para peserta Bincang Bahari webinar series 7 yang diselenggarakan oleh Balai Riset dan Observasi Laut, baik yang hadir melalui Zoom ataupun yang menyimak melalui channel YouTube BROL. Pertama-tama, marilah kita panjatkan puji syukur kehadirat Tuhan Yang Maha Esa, di mana kita masih diberikan kesehatan, keselamatan dalam melakukan aktivitas, di mana di masa pandemi ini tentunya kesehatan merupakan sesuatu yang sangat berharga bagi kita semua, sehingga kita bisa bekerja lebih baik lagi, dapat memberikan kontribusi yang lebih baik lagi kepada kelautan dan perikanan di Indonesia. I think in 1989, the Intergovernmental Oceanographic Commission, or IOC, called the initiation of a global ocean observing system, or we call GOOS. The purpose of GOOS is to provide a global framework or system to ensure global, long-term, systematic observation of the world oceans. GOOS is a sustained collaborative system of ocean observation encompassing in situ network, satellite system, governments, UN agency, and individual scientists. A better understanding of ocean climate and ecosystem, as well as human impact and vulnerabilities, require the coordination of continued and long-term system of ocean observation. In this context, the GOOS coordinates observation around the global ocean for 3 critical themes: climate, operational service, and marine ecosystem health. Following the Bali Declaration on August 9, 2005, on the occasion of Indian Global Ocean Observing System, the Indonesian Ministry of Marine Affairs and Fisheries launched the national programs under the Declaration of Indonesian Global Ocean Observing System we call INAGOS. The purpose of INAGOS is to have a comprehensive and sustained observation the ocean climate phenomena and natural human-induced related disaster through setting up monitoring system and its predictive scheme for coast, strait, and the adjacent area of Indonesian Sea. I think following this activity in IMRO, di Balai Riset dan Observasi Laut, kami telah melakukan banyak kegiatan-kegiatan, melakukan riset-riset untuk mengeksplor bagaimana interaksi antara ocean, baik melakukan observasi di lapangan atau melalui modeling. Seluruh data dan informasi tersebut tentunya diharapkan dapat menjawab fenomena-fenomena yang terjadi di perairan Indonesia yang direpresentasikan melalui wilayah pengelolaan perikanan. Saya kira melalui kajian-kajian oceanografi ini tentunya harus dapat menjawab bagaimana dinamika-dinamika oceanografi berpengaruh atau terkoneksi terhadap kesediaan stok ikan dalam kaitan dengan perikanan tangkap ataupun pengaruhnya terhadap kegiatan-kegiatan perikanan budidaya, sehingga ini tentunya dapat menjawab isu-isu dalam hal peningkatan stok perikanan tangkap juga kesesuaian lahan untuk perikanan budidaya. Saya kira melalui web seminar yang dilakukan oleh Balai Riset dan Observasi Laut pada hari ini yang bertema Ocean Observation and Modeling to Support Marine Resource Management, ini merupakan satu wahana di mana kita Balai Riset dan Observasi Laut dalam hal ini Pusat Riset Kelautan sangat berbangga bisa menghadirkan pembicara-pembicara yang memiliki kompetensi yang sangat baik di bidangnya. Meliputi dari China yang merupakan mitra kerjasama luar negeri Pusat Riset Kelautan dan juga peneliti-peneliti internal di Pusat Riset Kelautan yang tentunya memiliki keahlian-keahlian yang sudah levelnya bukan level nasional lagi, namun sudah level internasional. So this seminar aiming to gain recommendation on gap and adjustment of ocean observation and model in order to optimize the system, improve integration across observing platform and regional network through national and international collaboration. Also, share understanding the same research progress on the ocean observation and modeling by speaker in order to support marine resource management. In the end, determine how to meet future user need, improve the delivery product, advance technology and service, and balance need, capabilities and knowledge worldwide. So I hope that through this webinar or Bincang Bahari, we can share our knowledge. Kita dapat berbagi informasi dan pengalaman dan keilmuan tentunya dari pakar-pakar yang sudah menyediakan waktunya di sela-sela kesibukannya, tentunya juga seperti Mbak Asmi yang rela begadang sampai malam menyiapkan beberapa cangkir kopi. Saya kira ini momen yang sangat bagus sekali kita bisa bertukar informasi. Kami sebagai di Pusat Riset Kelautan sangat mengapresiasi acara Bincang Bahari yang digagas oleh Balai Riset dan Observasi Laut. Saya kira ini harus kita pertahankan dan tentunya tidak hanya sebatas Bincang Bahari, namun ada aksi yang tadi disampaikan oleh Bapak Kepala Badan, aksi nyata terhadap Bincang Bahari tersebut, baik berupa kolaborasi secara real dan juga implementasi dalam hal pengembangan basis data tentunya nanti untuk mendukung pengambilan kebijakan di sektor kelautan dan perikanan. So I hope this seminar will be fruitful for all the participants. Then finally enjoy the webinar. Thank you for for your participation. Wassalamualaikum warahmatullahi wabarakatuh. Om Santi 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 Om.
Thank you, Dr. Nyoman. Now, ladies and gentlemen, before we move to the main agenda, let me tell you the rules of this webinar. The first, we will mute all the audio of the participant, and we will open discussion section after all the speakers finish deliver their presentation. And for all of you who have a question, can ask from Q&A and raise hand feature, and also for all of you who join on YouTube channel, can ask the question from the room chat. And all of the participants have to join this webinar until finish, because in the end of this webinar, our team will share the link of the materials and also link of electronic certificate. Well, ladies and gentlemen, without further ado, we will move to the next agenda, and the next agenda will be led by our moderator. She is researcher of Institute for Marine Research and Observation, Dr. Desi Berlianti. She is graduated her doctoral from Kyushu University of Japan. To Dr. Desi Berlianti, time is yours.
Bismillahirrahmanirrahim. Thank you very much, Mbak Wulan, for the introduction. Your Excellencies, Head of Agency for Marine and Fisheries Research and Human Resources, Ministry of Marine Affairs and Fisheries, Republic of Indonesia, Bapak Profesor Insinyur Raden Syarif Wijaya, PhD, Efrina, Head of Marine Research Center, Dr. Inyoman Radiarta, SPI, MSc, and also join with us, Head of the Institute for Marine Research and Observation, Dr. Teja Arif Wibawa, MSc, and also our honorable three speakers on today's webinar. Dear colleagues, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. I hope everyone stay healthy everywhere, wherever you are. Thank you to each and every one of you for being here with us today. That marks our 7th webinar of second series Bincang Bahari. I'm greatly honored to have this opportunity as your moderator on this webinar with the topic of ocean observation and modeling in the framework to support marine research management. This is an issue that is becoming more and more challenges arising, bring to our attention every day. So on this occasion, I have a couple of minutes before we get started to the speakers. So it's my pleasure to be able to introduce to those of you who don't know about it and to clarify what has been happening that is about the ocean observing strategy, which relates to the in situ observation and ocean model product, in part to help us to address the marine resources management issues that we face. And I believe that some of them here. So what I'd like to do in the webinar today is to give you a little sense. Hopefully the files can be shared. So what I'd like to do in the webinar today is to give you a little sense of how this program to be, its background, talk about the motivators and rationale for the ocean observing, talk about what the IMRO ocean observing strategy actually is, with the information of in situ observation and ocean model product. And also I'd like to mention an inventory that we've been conducting on ocean observing, and then spend quite a bit of the time focusing on or keep providing you an overview to try to scope out the outcomes of our activities, and then gives you a sense of what actions we are intend going forward. I hope everyone can see the slides. Okay. So as for beginning, the Indonesian Archipelago is one of the most important zone of marine biodiversity, where tourism, aquaculture, and fishing contribute to the regional economy. In conjunction, fisheries are as a key activity in rural areas and generate considerable local economic transfers. These marine resources are under threat as never before, with highly vulnerable due to unregulated illegal fishing, to climate change, and to anthropization processes leading to the degradation of marine ecosystems. Every year, illegal fishing deprives of the Indonesian government and the fishermen. Global warming, pollution, and coastal deforestation are threatening these natural resources. The management of marine resources and fisheries is therefore highly complex and difficult, and constitutes a major issue for the country. So in order to apply the ocean observing strategy, in order to apply the ocean observing system, as we know that we need to consider multiple pressure on Indonesian seawater on subseasonal to decadal time scales. For example, an IOD and ENSO impacts to the ocean characteristics of our Indonesian seawater, which relates to the fish migration, capture fisheries, and its carrying capacity, while at some locations there are issues of coastal pollution and oil spills. Therefore, the motivators and rationale of IMRO's observing strategy are the Indonesian archipelago needs an observation, analysis, and ocean prediction continuously and simultaneously in order to understand the ocean characteristic and regional and global scale. The second is program of ocean observation system in long-term scale are important to meet future user needs related to marine resources management. Based on the motivator and rationale that we show on previously slide, the strategy is to combine all observation which conducted by IMRO from the field and satellite observation, ground station operational, and oceanography model products. They are all in the framework of the IMRO Ocean Observing System, namely SIDIC or System Prediksi Kelautan. Furthermore, the information system that contain data and information about marine coastal research conducted by IMRO are disseminated from the link of www.bipol.litbang.kkp.go.id/sidik. So you can go directly to the site to try. And being aware that a sustainable use of the ocean is one of the main challenges and requires strengthened cooperation at all levels to fulfill the need and to develop ecological management approach, considering various issues on exploitation of marine resources. Institute for Marine Research and Observation IMRO has been tasked by the Ministry of Marine Affairs and Fisheries Indonesia with providing ocean data and information obtained through research, observation, and monitoring. Considering complexity of ocean system and an enormous stretch of ocean crossing various countries, several international partnership programs were initiated by IMRO, including Southeast Asia Center for Ocean Research and Monitoring, or SICOM, Indonesian Global Ocean Observing System, INAGOS, as explained before from Dr. Nyoman Radiata, and also APEC Ocean and Fisheries Information Center, AOFIC. The SIDIC system hopefully will determine how this meet future user needs, improve the delivery of products across the stakeholder with advanced technology and services, and balance needs, capabilities, and knowledge worldwide. So in line with the program and to facilitate scientists on the need of Indonesian oceanographic data, including data exchange, IMRO scientists and engineers are developing a system called the Observation and Modeling Information System, or OMIS, as one of part of SIDIC platform. The platform is a web-based data tool that compiles and archives oceanographic surveys data conducted by IMRO scientists, and also ocean dynamics generated from physical and biogeochemical model products. Some features from OMIS are the data and information exchange of cruise program and product of ocean models, as we can see on this slide. So considering ocean observation, this is some summary for all program of cruise that conducted by IMRO scientists, collaboration with another institute, national and international. So this is the example of OMIS site. The link is bipol.litbang.kkp.go.id OMIS/OMIS. So the inside of the site, like you can see here in the slides. So we can choose some features such as in situ observation, ocean modeling, metadata, information, and some value-added service. Considering ocean observation requires strong network and sustainable partnership among oceanographic centers, the OMIS will also become a platform for data exchange, allowing wider coverage of the ocean, including its dynamics, to be frequently and continuously observed through an integrated system. So many efforts have been made to understand and predict the Indonesian waters on subseasonal to decadal timescales, while our knowledge still remains at an insufficient level to fully resolve challenges arising. Furthermore, model simulation and predictions involve large uncertainties, particularly due to lack of understanding of ocean characteristics across different spatial and temporal timescales, and due to multiple physical processes underlying others impacts due to multiple pressure on Indonesian waters. So this webinar aims to share current knowledge and methodologies to identify the unresolved issues toward further understanding and improve observation and prediction of the ocean characteristics and its impacts. This would also benefit the areas of marine resources and fisheries. So on this occasion, we shall have outstanding presentation from our prominent presenters, whom I believe shall enrich our insights and knowledge regarding the theme of this webinar. We have about 15 minutes allocation time for each speakers to deliver their presentations. Before the presentation begin, allow me to introduce a little bit about the presenters today. I'm glad to welcome all presenters, starting from Dr. Asmi. It's so good to have you here. Good evening. All right, beginning with Dr. Asmi Marintanapitu, a senior researcher of IMRO. Her educational qualifications are as follows. She attained her bachelor and master degree from Bandung Institute of Technology, and she attained her PhD degree from Columbia University, US. And second speaker, Dr. Jason Wei. Good afternoon. Thank you so much for being here joining us on this webinar. Dr. Jason Wei is a senior research scientist, research professor from Laboratory for Regional Oceanography and Numerical Modeling, Qingdao, and head of National Laboratory for Marine Science and Technology, the first Institute of Oceanography, State Oceanic Administration, Qingdao, People's Republic of China. And third or last speaker, he is from Marine Research Center, Dr. Dwi Yoga Nugroho, STMT. Assalamualaikum warahmatullahi wabarakatuh, Mas Yoga. Hope everything goes well.
Yes, Waalaikumsalam warahmatullahi wabarakatuh. I'm now in Sanur with Bayu and other teams. We are conducting a survey. Everything is fine.
Hope everything goes well.
Yeah.
Our third presenter, last but not least, is Dr. Dwi Yoga Nugroho. He is a researcher of Marine Research Center. His educational qualifications are as follows. He attained his bachelor degree from University of Indonesia, then attained his master degree from Bandung Institute of Technology. And he attained his doctoral degree from University of Paul Sabatier, Toulouse, France. So without further ado, I would like to welcome the first presenter, Dr. Asmi, to deliver the presentation. And today she will be sharing with us her subject on, please correct me if I'm wrong, Indonesian ocean observation and its relation to marine resources management. With that, I ask that you give your full attention to Dr. Napitu. Dr. Napitu, please.
Okay, can you hear me now, Uni Desi?
Clearly.
Okay, great, thank you. So, first of all, I would like to thank you, Pak Sarif. Sarip Wijaya, because he gave me actually a really nice introduction. So the goal of my talk actually his speech. So I was lucky today that he gave me a great introduction for my talk today. And also I would like to thank to Pak Nyoman Radiata. He was our boss in IMBRO until 2 weeks ago, and then he got a promotion. Now he's a head of Center of Marine Research in Jakarta. He moved to Jakarta. Also, I would like to greet our new head of IMRO, Pak Teja Arif. Hi, Pak Teja. So today, my talk, I would like to talk about what happened in 2016, which is the unprecedented ocean-atmosphere interaction in, all right, it's a little bit annoying. I need to, okay. Okay, the unprecedented ocean-atmosphere interaction in the Indonesian. So what happened in 2016? May not stay in 2016. That's the actually my talk today. So I know some of you doesn't know me. My name is Asmina Pitu. I work in Institute Marine Research and Observation. So what happened in 2016? The easiest way to answer this, of course, let's read some newspaper. So here two news are among many news that basically tell a similar story during summertime 2016. So the first one is the first news tell us that the fish catch is low because fishermen couldn't go out to sea due to a bad weather. So this is in Southern Java. And this one, the next one is, this one is actually, I was so excited when I read this because the news, it's not, I wasn't excited because they have a bad thing happen in 2016, but I was excited because the local fishermen close to our office in Prancak. So they say, the fishermen in Prancak say that they have a devastation because the fishermen, because their fish catch was extremely reduced by up to 50%. So essentially, the fisheries sector in 2016 was quite challenging in 2016. Why? Because they have a low fish catch. And then also they have extreme weather, so they cannot go out to the sea to catch the fish. So I think the fisheries sector is not the only one who got affected in 2016. So why this happened? Can we predict this kind of event so we know how to handle similar thing in foreseeable future? So in my understanding, in order for us to be able to provide an accurate suggestion to the society, to the stakeholder, I believe that we have to understand the process in the ocean and atmosphere that control this event. So I'm an oceanographer and I'm a researcher in KKP. So what happened in the ocean and atmosphere in the region during 2016? So what we're gonna do is, let's see the data. Okay. What's happening? All right. So the most available data that really helpful, of course, satellite data. So let's see SST, sea level anomaly, and wind stress. First, this one is a climatological mean. I refer that as a normal condition. Seasonal SST during June to September in the southern Indonesian seas, including off southern Java coast, is relatively colder because of winter season in southern hemisphere. So, and also we have upwelling system related to the southeast monsoon wind. So that's why this season is usually fishing season for the Indonesian fishermen. So the colder SST here, due to the upwelling system, is also very clear in sea level anomaly data. So southwest monsoon wind along the coast generate Ekman transport away from the coast, and that cause upwelling that reduce SST and sea level. Let's see the 2016 data. The 2016 data is actually the opposite of this, let's say, normal condition, right? So the SST of Java, it's warmer than normal. It's about 2 degrees. The warmer SST of Java due to the weaker upwelling system, which was driven by weaker monsoon winds along the coast of Java. It also reflects on higher than normal sea level anomaly along and off the coastline. So, based on the satellite data, we learned a fact that boreal summer 2016 was an unusual season. That's not normal at all. So indicated by significantly weaker upwelling system of Java coast. So what caused that unusual system? Why the SST in southern Java is warm? So now let's see in situ data. In situ data usually give us more detailed information, right? So luckily we have a mooring in Labani Channel in Makassar Strait. So KKP and KKP, IMRO, Institute Marine Research for Observation, together with Columbia University, maintain a mooring in Makassar Strait for more than 10 years. For more than 10 years between 2003 to 2017. So this mooring was intended to observe the Indonesian true flow. So before we see the ITF data in 2016, let's refresh our memory about the general behavior of the ITF. So the ITF responds to the pressure gradient between Pacific and Indian Ocean and then transfer heat water together with salt and heat from the Pacific to the Indian Ocean. So the ITF variation is sensitive to ENSO seasonal, intra-seasonal time scale. So while we we put mooring here in Makassar Strait, because Makassar Strait is the main channel for the true flow in the Indonesian seas, because about 80% of the total ITF runs through Makassar Strait. That's the reason why we maintain a mooring there, because we can monitor long-term variation of the ITF by only one mooring. So from this figure, we can see that the ITF transport is normally strong during boreal summer and weak during winter. So larger transport during summer because of, again, higher pressure gradient. So based on long-term ITF data that we have, we understand that mean transport on the ITF is around 11 sped drop during summer and around reduced to 8 sped drop during winter. Here is the ITF transfer from the long record in Makassar Strait upper 300 meters as indicated by the red curve. The blue curve is the climatology on the transport based on the red curve. So the negative sign indicate transport into the Indian Ocean. For example, the observed transport during 2007 to 2011 was larger than its climatology, which means more transport to the Indian Ocean. So as I mentioned before, remember that the true flow is due to the inter-ocean pressure gradient. So here we have a pressure gradient represented by the sea level difference between the Western Pacific and Eastern Indian Ocean, as shown by the black curve. Again, if you see the blue curve here is the climatology based on the black curve. So positive sea level difference indicates sea level over the Pacific is higher than over the Indian Ocean, or pressure gradient into the Indian Ocean. So it is clear these two are correlated. Larger transport correlate with positive sea level difference. For example, between 2007 to 2009, the sea level difference is larger than its climatology, which indicate larger pressure gradient into the Indian Ocean. So the larger pressure gradient correspond with more transport into the Indian Ocean. So during the ITF observation that we have here, there are significant ENSO and IOD events. Let's say I want you to direct your attention to what happened in 2016, during which a significant difference between the transport and its climatology took place. So it coincide with a higher sea level over Indian Ocean than normal. It takes place after the big 2015 El Nino, is very famous, and coincident with a very strong negative IOD. So let's see closely to the data in 2016. So in summer 2016, ITF transport in the upper 300 meters was substantially reduced by up to 40% relative to its climatological mean. So the transport anomaly is the difference between the observed transport and its climatology. The transport anomaly in 2016 is the largest anomaly on record compared to previous year. So the transport anomaly appears to relate to a large anomaly in interocean pressure gradient. And the anomalous transport and pressure gradient coincide with an extreme negative IOD, unusually strong during summer. Usually IOD event strong during fall season. So as a reminder, negative IOD events when we have sea level and SST over the Eastern Indian Ocean is higher than normal. So does the substantially reduced ITF transport during summer 2016 relate to the negative IOD? As a reminder again that we usually when we have a variation of the ITF, when we have reduced ITF or we have more ITF to the Indian Ocean, we always correlated with the ENSO event. So it's quite rare we connected it to the IOD event. But let's see, is it like related to IOD or is it related to the ENSO? So to explore possible mechanism accounting for the reduction of the ITF in summer 2016, we regress the ITF transport anomaly to SST and wind stress over Indo-Pacific. So every SST and wind stress data here, we regress to here. So why we do this? The regression helped to the relation between the ITF and the basin scale climatic forcing. So the regress SST and wind stress here for reduced ITF at zero lag, the reduction here, the reduction ITF, the reduction of ITF in the zero lags actually mimics the negative IOD. So this one, if you want to have reduced ITF, we're gonna have the IOD event. On the other hand, if you want to have increased ITF, we actually have a positive IOD. So if you see here, the transport anomaly appears to relate to a large anomaly in interocean pressure gradient, right? So this pattern includes warmer SST of Java, colder SST of Africa, and westerly wind bursts over the external Indian Ocean, and cyclonic winds over Bay of Bengal, and that's a characteristic of the negative IOD. So in addition to the regression of, regress SST and wind, we also have regress surface current and sea level in the region. So again, as a reminder, the reduced ITF transport also correspond with the eastward jet along the equatorial Indian Ocean here. So what happened is that westerly wind along the equator generate eastward current that cause mass convergence here, right? And then increase the level here. And then because of that, decrease the pressure gradient between the Pacific and Indian Ocean, and then reduce the ITF. We also want to see other data. So we use data from Rama mooring. For example, the mooring at 80 East. The Rama mooring 80 East recorded very strong eastward wind stress and eastward current prior to and during the negative IOD. Interestingly, the peak of the wind and surface current appeared to be 2 to 3 weeks before the largest reduction of the ITF in mid-June, which is also consistent from the correlation between the zonal current at 80 East and ITF transport anomaly in Makassar Strait as shown here. So what happens? It looks like the westerly winds along the equator also generate downwelling Kelvin wave that propagate into Makassar Strait within 2 to 3 weeks. So the propagation of wave is evident from this from this plot, right? Time longitude plot of sea level along this red line. We saw a clear propagation from the equatorial Indian Ocean to Makassar Strait. So now we can tell, based on all the fact that we see, that in summer 2016, the SST of the coast of Java was warmer than usual by about 2 degrees. The warmer SST was due to the extreme negative IOD, which was triggered by stronger than normal eastward equatorial currents and Kelvin waves. So the waves and current caused sea level of Java and Sumatra increased, which reduced the pressure gradient between the Pacific and Indian Ocean, and then explain why we have weak ITF in the upper 300 meter. So the warmer SST account for reported low fish catch in the region. That's answer the question why our fishermen cannot find fish when they go to the fish. So the extreme negative IOD was triggered by the strong equatorial jet and Kelvin wave. But the interesting part is, remember I mentioned that during the period of 2003 and 2014, the ITF increased. It's also one of the trigger the negative IOD that we see before. Desi, do you know how many minutes that I have left? Hello?
Not cut the time for you. Special.
What? Yes, would I see how many minutes? I can like make it like quick. Can I have like 5 minutes more?
Yes, yes.
Thank you so much, Desi. You're my best friend. Okay, so remember I mentioned that one of the problem why the fishermen couldn't go to the sea. They say that they have a bad weather. So it's impossible for them, it's not safe for them to go to look for, doing their activities. So we understand the low fish in September and June 2016 due to a weaker upwelling system, right? So what about the extreme weather? So based on our analysis in the ITF data in Makassar Strait, particularly the transport near the surface layer, we argue that the extreme weather in 2016 was related to the Madden-Julian oscillation, which was unusually very strong during summer 2016. So before I show you the data, the MGO evidence from the ITF data in 2016, just a little bit explanation about the MGO. So the MGO is an atmospheric tropical convection that is typically generated in the Indian Ocean at intraseasonal timescale between 20 to 90 days. So the MGO propagate starting from Indian Ocean and then propagate with phase speed 5 to 9 meters per second. And the MGO has two phases, passive and then followed by the active phase. So during the active phase, the MGO causes a problem because it brings a lot of precipitation that causes flood in Indonesia. That's why during December, January, February, the BMKG gave us a lot of warning because the MGO propagate over Indonesian seas. So I'm just gonna make it quick. So the MGO usually strong during December, January, February. So this one is just only illustration. I'm using the OLR data as a proxy for MGO event. So I just want to show you that the MGO in Indonesian maritime continent usually strong during December, January, February, but usually is very weak or low activity during summer. But in 2016, the MGO is so strong. So why is that? Let's see. So this the rainfall. So this is a typical summer that we usually have. We usually have a low precipitation, but in 2016 we have like high precipitation here. So this is the data from 2016. So now we see closer to the surface in the upper 100 meter. So the observed ITF transport anomaly in 2016 indicated by the red curve is partly due to the intraseasonal variation as shown by the blue curve, and the intraseasonal anomaly coincides with the convective phase of a summer MGO propagating eastward from the central Indian Ocean to the Western Pacific via the maritime continent. So the MGO activity activity here is represented by the RMM index with amplitude. If it's amplitude higher than 1, we say strong MJO. So the MJO system can be identified from this time longitude plot of LR average across the tropics, showing a continuous propagation of suppressed convective system from Indian Ocean all the way to the Western Pacific, which is again not common during summer, but occurred in 2016. So focusing on the dynamic response of Makassar Strait to the MJO. So during the suppressed phase, easterly winds and prevail from Java to Banda Sea. Here, the active one. As expected, during the active, we have less cloudy sky indicated by the OLR solid contour spot here, and dominate over the region during the active phase. So the westerly wind set creating high pressure of Java, reducing the interocean pressure gradient, and convecting system dominate the OLR. So the MJO winds along the Makassar Strait are northward, exerting northward momentum working against the ITF. So this is my last slide. So to assess the role of the MJO to dictate the ITF variation within the upper 100 meter, we compute the contribution of long straight pressure gradient, wind stress, and Coriolis to accelerate the layer here. So we're using the momentum budget to show that excess of northward momentum due to the pressure gradient over northward momentum attributed to the vertical divergence of Reynolds stress govern the northward acceleration of the surface layer during the active phase. So as a conclusion, so we have two issues in the news that I showed you before, that in 2060 we have unusually low fish catch and extreme weather, which is indicated by increased rainfall. So the SST of the southern coast of Java, Bali, and Nusa Tenggara Island was substantially warmer than normal, resulting in kind of disappearing of the upwelling system. So the unusually warmer SST in 2016 coincided with an extreme negative IOD event. So heap content buildup due to more ITF transport between 2003 to 2016 fueled the emergence of the negative IOD during summer 2016. So the MJO was also unusually active during summer 2016 over the Indonesian maritime continent, caused extreme weather and reduced ITF transport. So more active MJO during summer 2016 correspond with the negative IOD. This summer MJO is now currently our research topic. So lesson learned from this study is that observation always provide us a new insight into how the ocean and atmosphere function and impact the society that always surprise us. To come up to the best suggestion for the society, we need to keep improving and updating our understanding of how the ocean and atmosphere work through continuous observation. So we should not stop learning. We should not stop to observe the data. I understand the observation is relatively expensive, but then the final goal of the observation is to serve the society. I hope that by give this case, it kind of like convince you that how important this observation, because we need to improve our understanding about the relation between ocean and atmosphere. Thank you, Uni Desi. I think I'm gonna stop right here.
Very much, Mbak Asmi, for giving such a informative and interesting presentation. To participants, please hold all questions until the designated question and answer portion of the session. So now we go to second speakers, Dr. Jason Wei. He will be sharing with us his subject on ocean observation and modeling to support marine resources management. With that, I ask that you give your full attention to Dr. Jason Wei. All right, Dr. Jason, the floor is yours.
Hello. Can you hear me? Can you hear me?
Yes, yes.
Okay, okay. Thank you. Thank you, Dr. Desi Variability. Good afternoon, everyone. I'm Zexun Wei from the First Institute of Oceanography Ministry of Natural Resources of China. It's my pleasure to take part in this seminar and introduce our latest study about the South China Sea branch of the Pacific to Indian Ocean through flow. This study was integrated by some researchers from China, from Indonesia, from USA, and for the 10 years. And our collaborators are mainly from FIO of China, MMAF of Indonesia, and the UN of USA to Central. And firstly, I should congratulate the 50th anniversary celebration of IMRO. Congratulations. And before my presentation, I will give a short review of our great cooperation between FIO and MMAF since the year of 2007. We have collaborated with MMAF, especially IMRO, to set up a series of the great international marine science project. For example, CITER, JUVO, this is for the Java Upper Valley, and MONSEE, and the TIMIT, and something, and so on. So our great cooperation has lasted for more than 10 years. And those projects not only improve our understanding about related scientific problems, but also increase our friendship between FIO and MMAF, I think. In following, I will share our new results from CITER and TIMIT project. This is for the South China Sea branch of Pacific to Indian Ocean through flow. This is a global ocean conveyor, which is a constantly moving system of deep ocean circulation, which are driven by temperature and salinity, as we know. And as we know, it plays a very important role in global transport and the climate system. The transport between Pacific to India Ocean is one important part of Great Ocean Conveyor here, and is one only pathway which connects with Pacific Ocean and Indian Ocean in the tropical ocean, and it is named Pacific to Indian Ocean Through Flow, PIOT. And PIOT, Pacific to Indian Ocean Through Flow, includes two paths. The main flow is Indonesia through flow. It is well known. On this pathway, there is the Makassar Strait, Lombok Strait, Ombe Strait, and Timor Passage, or something like that. Recently, we found that a freshwater branch is found. We found that there is a new branch for the Pacific to Indian Ocean through flow in South China Sea, which through South China Sea and the Java Sea. So we sometimes we named it as the South China Sea branch of Pacific to Indian Ocean through flow. The annual mean volume transport of the Pacific to Indian Ocean through flow is about 10 severe loop, with heat transport at about 0.5 to 1.2 petawatts which is comparable with net surface heat flux over the West Pacific warm pore. So it is very large. For the Indonesian through flow, we know that based on the ship drift observation, Whitkey firstly gave the Indonesia through flow pathway like this. This is for the boreal winter, and this is for the boreal summer. It plays an important role in Western Pacific Ocean circulation and climate system, and it can directly impact on the basic, the heat and the fresh water balance between the two bays, between the Pacific Ocean and the Indian Ocean. Up to now, the successful and comprehensive observation for ITF is instant, and it's extending projects. It is an international cooperation project among Indonesia, USA, French, Netherlands, and Australia. The MMAF IMRO is one of the leaders of this project and make an outstanding contribution to this project. And the kind of the instant project, the measurement of the ITF is simultaneous, multi-year, and in all the major inflow and outflow passages, but not including the west part, for example, Makassar Strait and Sunda Strait. So this is for the Makassar Strait observation. Observation of instant and its continuation shows that the Makassar Strait is the main conduit for the inflow of Pacific water into the Indonesia seas. Carry about 18% or more of the Indonesia's rainfall water. In Makassar Strait, there is a velocity maximum within the salmon line, which is about 15% greater than the surface layer flow. The Makassar through flow also shows obvious seasonal and interannual variability, and the interannual variability is related with inflow, as we know. And up to now, the ITF observation in Makassar Strait can cover the period from the 1997 to now, and still is continued. This is a velocity profile is given by Gordon in the last year, in the year of 2019, published on JGR. So it is a very, very good observation and a very good study for the Pacific Indian Ocean through flow, and give us so many knowledges for the ITF. And for the outflow passages, the instant moorings were also deployed in 3 major outflow passages. The Lombok Strait and Ombe Strait and the Timor passages. During the same period of the year of 2004 to 2006, the measurement of currents, the ocean currents in those straits reveals seasonal cycle, as well as semi-annual and intraseasonal variabilities induced by the propagation of equatorial and coastal carrying waves that forced remotely by the equatorial Indian Ocean zone. winds. So for the source of the water mass of Indonesia's through flow, our recent study, we used the passive trains of numerical simulation, shows that not only the North Pacific waters, but also the South Pacific waters can contribute to ITF. There are 4 pathways for the South Pacific tropical water and the Antarctic intermediate water through the maritime continent, including the two direct pathways named the East Path and the Torres Strait Path. East Path and Torres Strait Path, and the 2 indirect pathways named the West Path and the South China Sea branch. So we think there are 4 paths for the South Pacific water contribute to the ITF. So of the South China Sea, for the South China Sea path, it relies on the South China Sea branch. And this is a result of Savitsky in 1961. He shows the circulation pattern in the South China Sea in winter. The left is winter and boreal winter, and the right figure is summer. And he suggested that the southward water transport from South China Sea to Java Sea in winter, and from south to north, it means from the Java Sea to South China Sea in summer, driven by monsoon. But his estimation of the transport through the Karimata Strait contains large uncertainty due to limited measurement, because he just used the drifters, the data. So after that time, the Karimata Strait transport has been overlooked for decades. And about 20 years ago, in the year of 2002, we have set up a numerical global ocean model. This model is a variable grid ocean circulation model. So in the Northwest Pacific and Eastern Pacific and in Eastern India and in South China Sea, the resolution is very, very fine. So based on the results of this model, we found that there should be cross-basin flow through the South China Sea. This is in winter, and this is in summer. And also we found that maybe there should be a through flow. There should be a cross-basin flow based on the trajectory of the drifters satellite. And so I think we think at that time we guess that there should be the South China Sea branch driven by not only seasonal reverses monsoon, but also large-scale sea surface slope. Thus can be named as the South China Sea branch of the Pacific to Indian Ocean through flow. And it would be greatly improve our understanding about the heat and salt bedding of the South China Sea and the Java Sea, its regional impacts. And the opportunity sooner came 4 years later in 2006. By the way, the South China Sea branch was confirmed by Argo, observation in 2005 by Professor Fang Guohong and by water mass analysis in 2006 by Qu Tangdong from US, who named this branch as the South China Sea through flow. Here is a brief result of our numerical model as measured, as I measured before. The annual mean volume transport is 1. It is very small, 1.16 severe from the South China Sea to the Java Sea here, and through the Karimata Strait with heat transport is 0.113 petawatts, and the fresh water, this is a fresh water budget. Fresh water transport is about 0.05 severe and flows eventually towards the Indian Ocean. Okay.
Pardon, Dr. Wei, you still have 5 minutes left.
Okay, thank you. This fresh water transport amount to 47% of the total net fresh water given over the South China Sea. Therefore, the Karimata Strait through flow act as an air conditioner, cooling and making saltier the South China Sea. And the South China Sea branch transport of the fresh water from the South China Sea into Indian Ocean, Java Sea. On the one hand, it will contribute to volume transport of the Pacific to Indian Ocean through flow, about 13% of the ITF. On the other hand, it will reduce the sound water transport of ITF in Makassar Strait by the fresh water track, which measured by Garden. And the maximum of the ITF flow appears in the subsurface layer, and it is related with the block of the fresh water of South China Sea branch. And because lack of the direct observation of the South China Sea branch in the Karimata Strait, researchers from the FIO and MMAF and the University of Maryland, USA, conducted a collaborative observation project, CITER, the South China Sea, Indonesia Sea Transport Exchange, since the year of 2007, and the incident project overlooked the Karimata Strait, as I mentioned before, in order to observation covering the entire water column in the inflow passages and outflow passages. The plan of the project is for the transport internal waves and mixing in the Indonesia through flow regions named Image, was signed by scientists from FIO and MMAF in December of 2013. And this is observer, the project site outlines an effort to measure the water mass transport, temperature and salinity and heat flux between the Indonesia Seas and South China Seas through the Karimata Strait. And I will give some results of the site research results. This figure shows the tide energy flux densities of the diurnal tide K1, O1, and the semi-diurnal tide constituents M2 and S2. The diurnal, this is a diurnal and K1 and O1. The diurnal tide energy flows from the South China Sea to the Java Sea, and the semi-diurnal, this is a semi-diurnal M2 and S2. Semi-diurnal, the tide energy propagation from the South China Sea to the Java Sea through the Karimata Strait and the eastern parts of the southern Natuna Sea, but flows from the Java Sea to South China Sea in the Caspar Strait and the western part of the southern Natuna Sea. And this is for seasonal variability. Based on HICOM results, we can find that the monthly climatology of the surface current in the Karimata Strait show obvious seasonal variation, and it is related with monsoon transition. And this is a seasonal variability also. The site observer current data reveals that the volume transport through the Karimata Strait has significant seasonal variation. The boreal winter average transport is greater than that in the boreal summer. The average transport is southward, which confirms the South China Sea branch. May and September are the transition period. In May, the current in the Karimata Strait turn to the northward, consistent with a local monsoon. In September, the southeasterly trend wind is still present over the strait, driving surface water northward, whereas the bottom flow reverses direction, possibility because of the pressure gradient across the strait from the north to south. And during the last 10 years, the climatological monthly mean transport through the Karimata Strait are shown in this table. There are 2.08 severe drop from South China Sea to the Java Sea in boreal South China Sea in boreal in winter, and 0.72 severe drop from the Java Sea to South China Sea in boreal summer, and for the annual mean is 0.78 severe drop from the South China Sea to the Java Sea, and for the interannual variability. Also, we found that there are also in the Karimata Strait, Karimata volume transport as shown by the EMD of the transport time series. This is we did some EMD analysis. Also, the interannual variation is revealed by wavelet power spectrum, showing a typical period of 1.8 to 3.1 and 2.6 to 3.8 years during 1993 to 2001 and 2004 to 2014 respectively. But we are not clear why there is a period shift toward low frequency. For the interannual variability of Karimata Strait transport, it seems lesser correlated by the two birds IOD and ENSO. Strong or weak interannual events of Karimata Strait water transport occur somehow in accompany with IOD and ENSO events, and the correlation coefficient of the transport anomaly with the DMI and the NINO 3.4 index are insignificant. And for the decadal trend, this is a EMD analysis result of the volume, heat, and fresh water transport of the Karimata Strait through flow. We focused on the residue. There is a decrease trend of the southward volume transport of 0.2 severe drop per decade over the period of the year 1997 to 2014, implying that volume transport towards the Java Sea has decreased as large as 0.26 droop after the year 2014. So today I have just talk about the Pacific South Pacific branch of the Pacific to Indian Ocean through flow. And as we know, the Pacific to Indian Ocean through flow, including ITF and South Pacific branch, both of them plays important roles in the water and heat exchange between the Pacific and the Indian Ocean. A series of in-situ observation focused on the South China Sea branch of Pacific to Indian Ocean through flow have been carried out, conducted through international cooperation project, site and teaming for longer than 10 years. And the South China Sea branch in the Karmata Strait through the Karmata Strait contribute to the transport of 2.08 severe droop in winter and to 0.72 severe droop in summer, and for annual mean 0.78 severe droop. There is a strong seasonal variability in the Karmata Strait through flow, and also intra-seasonal variability in the Sunda Strait through flow, and is mainly affected by local wind pressure gradient and Kelvin waves. And the interannual variability of the Karmata Strait transport is not significant correlated with IOD and ENSO. There are decreasing decadal trend of the Karmata Strait transport, but the reason we don't know till now. Further observation and study are expected to review the characters and the dynamics of the Pacific to Indian Ocean through flow and its South China Sea branch. That's all. Thank you. And I do hope the IMRO will be better and better in the future. And I do believe that our cooperation will have a more successful future. Thank you very much.
And Dr. Jason Wei for the great presentation, especially for explanation of some phenomenon based on observation and numerical model, especially for temporal scale phenomenon in some specific area. Now we go to last speakers, Dr. Dwi Yoga Nugroho. He will be sharing with us his subject related to ocean modeling development to support marine resources management for regional and local perspectives. With that, I ask that you give your full attention to Dr. Dwi Yoga. All right, Dr. Dwi Yoga, the floor is yours.
Okay, thank you very much. Hello, everybody. So I'm going to share my screen first. Here you go. Yeah. Okay. Good afternoon, everybody. So I'm gonna talk about the model, because my expertise is in modeling. It's actually, this is not so scientific. It's not too scientific. So this is just only a very relaxed interview, very relaxed presentation, and then we can have discussion later. So this is the outline of my presentation. I will share about the introduction of the presentations, about the Indonesian seas, and then why do we need the ocean model, and then I will share about some experience, my experience in the INDESO project, this operational oceanography project in Indonesia, and then the future development, my dream, my hope, my efforts until now to develop the numerical model, the operational oceanography in Indonesia. First, I would like to share about the oceanographic conditions. This is the uniqueness of the Indonesian seas, because the Indonesian seas is located between two oceans, and there is a density gradient transport from the Pacific Ocean to Indian Oceans. The previous presenter, Jackson, already explained about this. And then the transport is about 6 to 8 sphere drop from Pacific to, and then going out to the Indonesian Ocean. And then also the Indonesian seas has a unique water mass transformation that it transforms the warm and the saltier water mass from the Pacific Ocean to the Indian Oceans. And it's very interesting. And also we can see here that there is a vertical mixing happens in the Indonesian seas. This from observation, we can see that the maximum salinity from the Pacific, the North Pacific and the South Pacific, this is actually the figure of the temperature in the y-axis and the salinity in the x-axis. You can see here that the maximum salinity from the Pacific Oceans entering the Indonesian Ocean, you can see here the dot color. The maximum salinity is eroded to another profile when they entering Indonesian seas, and then we can conclude that there is a very strong vertical mixing happens in this region. Also, the Indonesian seas play a role in the ocean atmosphere. So if we conduct, this is for a paper from Arjen Kutslar 2009, that we developed, she developed the coupled ocean atmosphere model that the Indonesian seas can reduce the precipitation by 20% because it can reduce the SST by 2 degrees Celsius. The reduction of the SST is mainly because of the vertical mixings happens in Indonesian Indonesia Sea. So it can make some cooling effect from the vertical mixing happens in the water column, can create the cooling effect to the surface, and it reduce the SST and then reduce the precipitation. So the couple between ocean atmosphere is very, very important in the model. And then why do we need an ocean model? This is very general questions, also scientific questions. But as you know, the Indonesian region is, Indonesia is very, very large. There are very, very long coastline, and then there are more than 17,000 islands. And then the area of the ocean is very, very huge. And then we also have some coastal vegetation, and then also the home of millions of fish. And for all these resources can give food and can give food to the people of Indonesia. So and then since 1961, that is the first observation from the ship. There's information that the oceanographic condition in Indonesia, mainly in the surface, because at that time we don't have any technology to model, and we don't have any technology to simulate the water column, the three-dimensional water column of the Indonesian seas. So these figures you can find in many publications until now. I don't know why you still use this figure, because it's also, this is actually this is the first figures, but until now the people, the students of the university, or maybe I found some researcher that using this, that refer to this figure to see the oceanographic condition in the surface. And then also the Indonesian seas plays as a role in the climate and weather studies. That is, it is the region of the whirlpool, and then it's a passage from the planetary wave, the Kelvin wave, and the Rossby wave. So, and then as Zeksun and Asmi already share their experience about the observations. The two things, the model and observation, have limitation. What is the limitation of the observation? Yes, the limitation is, I can show you here that if we measure the ocean parameter from the instrument, we can have the real data, and then it's the truth. The real data is the truth, but the sampling is probably insufficient. You can cover all the Indonesia seas with the instrument, And then for the real-time data, for the long-time series data, you need for the 3D profile, you need an Argo. It can give a good sampling, but in some regions the Argo cannot reach because the bathymetry of Indonesia, we have very many shallow bathymetry, and that's the limitation of the observation. And also the observation is lack of in time and space, and then we need some tools to cover the gap in the time and the space between observation data. And the tools is the model. This model is just to solve the equation, the four-dimensional equation, the time and the space, and then it's solved mathematically using numerical methods. But also the model has some limitation. First, the boundary condition. We need a very good boundary condition, and then the resolution. For example, if you want to have a very good turbulence, the resolution, the turbulence dynamic is in the millimeters. But if we want to make a model for example, the Indonesian true flow with the longer time scale and very wider space, the model cannot resolve from the millimeter to the very large to up to kilometers. And the best strategy is use both model and observation. And this is I think all the oceanographers want to have some collaboration, some data transfer, or some discussion between the observation data and also the modeling data. So actually, this is some tools that is very familiar in Indonesia. We have the regional model. Some tools are commercial and some are free commercial or free academics. And many students, many companies use these tools to make a model in Indonesia. There are also the scientific, ocean general, regional models. For example, the ROMS, CROCO, NEMO, some with the different capability, different special grid type, and then different vertical grid, and then with each of the scientific model has many different numerical sim, and then different computational. And then that's the previously I already talked about the models, and then I will talk about the industry project. The industry project was the first project that using the numerical model, the ocean general circulation model, in order to have the operational oceanography in Indonesia. The model has already stopped since 2017. It's not bad. It's the project start for 4 years, and it provides for the 9 days oceanographic 3-dimensional, including biogeochemical. There are 24 parameters for the biogeochemical. It's a prediction of 9 days predictions. In a 112-degree resolution, it's about 10 kilometers. But unfortunately, until now, the program is stopped. The challenge in this model, this is the challenge when I joined in this model, and when I work when I using the models, when I make a model during my PhD. The Indonesian region is the most challenges region to make a model, because the bathymetry is very sparse. There's a very shallow bathymetry, and then very deep bathymetry in the Banda Seas. And as you know, the coastline, there are 17,000 islands. There are many complex coastline, and lots of river input, and etc. Yeah, this is the configuration of the Indonesian model using 112-degree resolution. This is the configuration, but the model is very sensitive. I show you my sensitivity test using the models in Indonesia, and maybe this is I can show you here. This is the TS, the temperature and salinity diagram in Banda Seas. I want to show you that the modeling in Indonesian seas is not as easy as that, because in many ocean model we have different numerical scheme. For example, there's some numerical scheme called the TVD, the UBS, the quickest numerical scheme, and also the forcing from the tides, and then we must parameterize some mixings. And you can see here that I made some tests with the different numerical scheme, different forcing, and it creates the very, very different water mass, this, for example, in the Banda Seas. So it's very challenging. And it's one of the results of, this is the results from the Indonesian model, the system phase temperature and the system phase salinity, and below is the currents in 10 meters depth. It's not bad, it's good, it's already evaluated, and there's a paper already published for this evaluation of this model. The product is just like a physical product. And then the future development of for the stakeholders. Actually, this is the main idea. The stressing point of my presentation is the future development. So the potential is, for example, I get this map from my colleague that you can see here that there are many oil and gas exploration. This is from the Directorate General for Special Management. So there are many companies operated in the Indonesian seas, and then there are conservation area nearby. So they need some oceanographic data real time, and also to detect the oil spill. Until now, if you want to make a model, for example, there is a oil platform in the Makassar Strait. You need a very realistic ocean current to model to detect the oil spill. This only for the example. And then the other ideas is this is actually the tribute from our last our previous Director General Aryo Hanggono. He about 2 months ago he asked me to come to his office and to make a discussion how to make the 3D marine spatial planning, because the 3D maybe actually the 4D marine spatial planning, including the time, the 3D space and the one dimension is the space. How to make, is it possible to make the Indonesian operational or the Indonesian marine spatial planning in 3 dimensions? I said yes, because and then we need tools to do that, and then I proposed to him to make the ocean to develop another ocean numerical model in Indonesia to make another project. It's like in Indonesia too. And then all the parameters from the model can be used as the input to the marine spatial planning in 3 dimensions. And then also the fishing zone. This is I got the fishing zone from the website, the KKP website. Actually, the fishing zone mainly is the source of the data mainly is from the satellite that the processing is to see the front, the difference, the temperature gradient, and then from the satellite, and also to detect the chlorophyll, the algorithm of to detect chlorophyll from the satellite, for example, from the MODI satellite. But unfortunately, we are living in the tropical region, the equator. There are lots of clouds and then lots of rain. So it's very hard to settle. It's very hard for the satellite to make a photo, to capture the image. And I hope maybe by using the ocean numerical model, we can have the prediction of the SST and the chlorophyll from the maybe more robust than the satellite data. And then this is another result from using numerical model that we can also detect the marine debris. This is the simulation. I made simulation from January to February 2020. The marine debris coming from the Jakarta Bay, and we can see here's the first. There's a different path of the marine debris. If the marine debris is released from January, and then marine debris is released in February. So in February, the marine debris, the particle will come to the Indian Oceans mainly, but when the release time is in January, the particle mainly going to the east part of Indonesia in Flores Sea. This is another simulation from in June and July 2020. So there's many utilization of using a numerical model, but unfortunately, we don't have it until now. There is a numerical model, and then with the colleagues from the BAHARI from Pangandaran, they already make some technology, the real-time technology, because the ocean model, we need the real-time observation to make predictions, better predictions. They already developed the automatic weather station, and the reason is they already developed the Puma. Puma is just like a device for the sea level measuring. It's real time, and maybe this is the first development with the cooperation with the European Union. It can give then some alert for this is ROP. ROP is coastal inundations. There's tropical cyclones coming to the south part of Java, and it increased the water surface elevation in the southern Java coastal. Southern Java coast. It's detected by this device, and the future development of this device also can detect the water temperature and then the salinity. And we need this technology in order to make the assimilation of our models. So actually, since 2000, since 2 years ago, I already just maybe this is information for Pak Nyoman. I already discussed with many directors, many boss in KKP that we need to have we have to have the more fine resolution of the numerical model. And then in the beginning of this year, there is I know that some colleagues in Lapan, they already developed the weather, the atmospheric model, and then the model is very good. I very satisfied with the models, and then I think how about to make a collaborations from the Lapan and then with the Ministry of Marine Affairs and Fisheries, so we can have the models, the coupled model for the ocean and the atmosphere. Why the coupled model is important? This is the recent publication from Su et al. 2020. There's a different coupled model for here. If you see the example, this is the bias of the rainfall. The coupled model, you can see the bias is minimized, and then the uncoupled model, it means the atmospheric model is just working by itself, not coupled by the ocean. We can see the bias is higher than if they coupled the model between the ocean and the atmosphere. And also the comparison here with the gauge, the rainfall gauge between the coupled and uncoupled model with the atmosphere and ocean atmosphere model, we can see here that the better very good agreement that if we couple the model, the agreement is better than with the if we compare with the rainfall gauge. So it's important in Indonesia and to have some coupled with atmosphere, and then maybe I don't have time to discuss with our new director, Pak Nyoman.
Mas Yoga.
Yeah.
You still have 3 minutes left. Okay.
Yeah.
Thank you.
Maybe I will talk later, maybe next week, about that. We have some collaboration with the Lapan and then to develop the coupled ocean atmosphere model. So this is my last presentation about the discussion. I just throw some idea to have a discussion that we can have the Indonesia have many opportunity to develop our own regional model, but we need to go collaboration. We need the forcing from maybe from the international institutes. I have a colleague from the China that is responsible in the ocean prediction. I forgot the name of the company because we were in the France last year. We were doing the same project in France, and then this is maybe the step how to develop the ocean numerical model in Indonesia. So we need a very good observation from the institute data. So I hope that there is still some cruise or oceanographic cruise will continue between Indonesia and China. Maybe oceanographic cruise by the Indonesian researcher, and then the very good data processing from the satellite observation. When we also develop the real-time observation from the instruments, and it's combined in the infrastructure, just like computer and etc. And yes, we can have the operation ocean model. Mainly the problem here is the infrastructure, because Indonesia it's very hard to buy a computer. It's about 4 to 5 billion, 5 million rupiah. It's very, very hard. It's very, very expensive. Maybe we can have a collaboration with other countries, and then the operational model, we give the historical and tradition data to many stakeholders, to the fishermen, to the researcher, to the students, and all the data can also used by the decision support, by the decision maker in the department, in the ministry. Maybe they can have many decision to about the management of the marine resources in Indonesia better. Okay, thank you very much. This is my presentations. Okay, thank you.
Thank you again, Dr. Dwi Yoga Nugroho, for the great presentation that explaining us about the need of ocean model, its challenges, and the future development for stakeholder. And before continue our session to my beloved colleague, Mbak Ulan, I'd like to request the opinion of following share screen to all speakers as shown on the screen. So first is about the recommendation on gaps and adjustment of ocean. The system, improve integration regional networks through national and international collaboration. And the second one is determine how to meet future user needs, also improve the delivery of products, advanced technology and services, and also the balance needs, the capabilities and knowledge worldwide. Achieving these outcomes will result in a fit for purpose ocean observing and model over the next decade. So hope this discussion part will encourage more questions from participants who join with us today in this webinar. All right, we can start from perhaps Dr. Asmi first, and then Dr. Jason Wei, and lastly Dr. Dwi Yoga. Please. Dr. Asmi?
Oh, okay, so I forget something. So first of all, I would like to share my screen. So for those of you who probably missed my talk today because the committee told me that I only have 15 minutes. So that's why I kind of like talk like 100 miles per hour. So I was talk so fast. So probably some of you missed my talk today. So I'm going to share my presentation to the committee so you can ask from them. And also I put, what is, all right, I put my information here, so this is my email. So if you want to ask something about my presentation and also you're interested to work with me using the data that I saw, I'm very welcome with you. And then this is my email. I love if you reach me through this email. And then I think, do I have a question, Unidesi? Stop share.
Recommendation on gaps.
Oh, the recommendation. I'm sorry. So what is the question again? The recommendation for what? Sorry, I'm quite jumpy here because of copy. So,
and especially for the relation between the observation and the application for the marine resources management. For real, yeah. You can see from the screen.
Yeah, I can see that. Can I skip for a moment? I need time to think. Maybe Dr. Wei Jackson can talk first, or Mas Yoga when I'm thinking. So the recommendation on gap and adjustment of ocean observation.
There is a raised hand.
Oh,
This, I see there's one attendee is raising.
Dr. Jason or Dr. Ryoga, perhaps you can give some perspectives due to the written on the screen.
Okay, I would like to share my opinion. For us, I think, firstly, I want to say that we want to continue our cooperation in the IPF and some China branch. For example, for the project, the TIMIT, the transport mixing, vertical mixing, and the internal wave of in the Indonesia's rural regions, something like that. So we want to continue our collaborative observation in these regions and to get more longer term of observation data and to do further studies on the transport and the vertical mixing or something like that. For that, I think we should do some more studies, such as I think we may do some combined research work. I mean combined the observation, field observation and the space observation. I mean satellite and the numerical modeling, such as we should use some numerical technical, for example, data assimilation and something like that. We should maybe it will be better if we can obtain the long time reanalysis data for this region or something like that, and this kind of data will be very valuable for the research on the environment and environment and the climate system. So I think it is very important. And another way is we should do our best to make a progress in the observation technical. For example, we besides of mooring, I mean buoy mooring. So maybe we need the real time subsurface mooring systems, so we can get the real time data from the subsurface mooring. So it is very important. So also I want to share our new results, new numerical techniques for the vertical mixing parameterization. We set up a new parameterization for the tidal induced vertical mixing, and we have got the not bad results based on this new parameterization. So this kind of parameterization scheme is very easy to use in different models. For example, RAMS, FVCOM, and NEMO or something like that. It is not very difficult to use this kind of new parameterization for the tidal-induced vertical mixing. It is very important because if we use the coupled ocean circulation and sea tides numerical modeling to get the real-time simulated results, it is very difficult. I mean, computation cost will be very high. But if we use this parameterization, it will be very easy, and the computation cost will be low or something like that. So anyway, for FIO, first the Institute of Oceanography, Ministry of Natural Resources of China, we do hope to continue our cooperation this kind of fields or something like that. So I do hope and to believe that we will have very good future for our cooperation. So it's all. So thank you. Thank you.
Thank you, Dr. Asmi or Dr. Dwi Yoga.
Yeah, Bu Haji. Okay, thank you, Dr. Wei. I couldn't agree more. I just love your conclusion, your perspective in the end, because the mixing is very crucial. It's very important in our in Indonesia. And yes, I agree that if we don't have very good parameterizations, we can waste our times in the computational, because you know, the computational will be very expensive. But in order to have a good parameterization, we need to have a lot of observation, the in situ data. Until now, many in situ data, I don't know, I'm not following the recent project, the recent cruise in Indonesia, but I saw some publications and in Indonesia that the mixing parameterization or the mixing coefficient is mainly calculated by the CTD. The CTD itself is, I think the CTD itself is also parameterized to calculate the mixings. So in order to cope, to have a solution, we need to have measurements that directly measure the turbulence using the instruments that are dedicated to use to measure the turbulence, just like the velocimeter, turbulence profiler, or something like that. And if we can have a good parameterization, we can have a very light computational cost to do the models. And the second one is maybe it is still an open question that we think that mainly oceanographer think the mixing is all the vertical mixings can give an effect to the physical parameters, the temperature, salinity, the density, but what will be happens into the biogeochemical, to the nutrients, and then is it some coupled effect with the vertical mixings and the biogeochemical mixing related to the vertical mixing of the physical parameters, and then something like that. That it is still an open questions for the scientists. And maybe if there are some research projects dedicated to measure the biogeochemical mixing, maybe it will be a very good finding for the world of the oceanography. And also my perspective is actually the why we need to conduct why we need to have the ocean numerical model in Indonesia, because we need the data, the real-time data. The Indonesian people, as maybe 20 years ago, 15 years ago, there's not so many people understand the effect of the temperature variability or the salinity of the tridimensional parameter of the oceans. But now, when the education system, the ocean, maybe maybe has already improved the information about the Indonesian seas. And you can find in Indonesia that there are some fishermen that understand how to read the SST data from the satellite, and it's very, very surprising. So maybe in the future, maybe in the 5 or 10 years and from now, and if we have the models and we can distribute to the fishermen, yeah, maybe it will be it will be very beneficial for them. And actually, that some of my perspective, I'm waiting for the collaboration, maybe with ASMI or maybe with Dr. Wei. Okay, thank you, Madam Ibu Haji.
Well, Barakallahu Fik, Mas Yoga. Thank you very much. Maybe Dr. Asmi?
Okay, thank you, Uni Desi. Just call me Asmi. It's just such a weird when you call me Dr. Asmi. Just call me Asmi. All right, so the recommendation on gap and adjustment of ocean observation. So basically the observation in IMRO, we kind of like provide observation data through satellite data, right? So we have observation data through satellite data, but then that's not enough. We need more detailed data. So we usually need a long-term observation data. Usually we have a mooring. So again, for more than 10 years, we maintain KKP and United States Institute from Columbia University from United States maintain mooring in Makassar Strait. That's like one of the example for us to observe Indonesian true flow. As I explained before, the Indonesian true flow actually from the data that we have from Makassar Strait, we can learn so many things. That is actually, it's not only important for scientists, but it's also the end of that is very, very important for our society. So we have the we have observation data in mooring, and then right now actually we have a lot of observation data. We have a lot of mooring. I believe Chinese collaboration, KKP collaborated with China, and also LIPI collaborate with China, United States collaborate with BMKG. Now we have a lot of actually observation. We basically right now we deploy a lot of mooring, but I don't know, this is unfortunate for me, is the data is quite scattered because for example, the for Makassar mooring, we keep the data in Institute Marine Research and Observation, right? But I don't know whether everyone know that. We hope that if everyone know that, they can use it as much as they can. So at the end, it's very useful. And then the next 5 years, we're going to have the BMKG working together with United States. We'll deploy a lot of mooring, and also they're gonna deploy several Argo floats in order to continue to observe Indonesian true flow. It's gonna be like the instant instant kind of instant project, and also the Argo float, they're gonna deploy Argo float. The BMKG gonna deploy the Argo float, but the BMKG actually is most interested with the how to use the ocean data for the weather and climate prediction. But for us in a fisheries section, we can use those data. So I think from Indonesian part, we have to collaborate between the agency, so we can save a lot of effort, a lot of budget to observe Indonesia. In order to fill the gap to the model, I think if we provide a good data, and then we improve our understanding about the ocean dynamic in Indonesian seas, I think the modeler like you, Uni Desi, like Mas Yoga, can improve your model to make it more accurate. So that's what my opinion about how we improve the gap, the gap of this. So right now we have a lot of observation. The only thing that we need to do is let's collaborate. So, and then I hope that the data that we have after several years, because you know, a researcher usually need like 2 years or 3 years to keep their data, to make sure their data is good enough. So, and then after the 3 years of data, I hope that we can share the data, especially among Indonesian scientists. And then I think with that, we can work together, and then we improve our understanding about the Indonesian dynamics, and then also with that we can improve our modeling. I think that's it, Ibu Desi. I'm just gonna stop over there.
All speakers for your interesting perspective and opinion. So this all. Now for the question and answer session, we'll return back to my beloved colleague, Mbak Wulan, that will direct you all for the discussion. To Mbak Wulan.
Thank you, Dr. Desi. Now we move to the discussion section. And we already open for the raise hand feature and Q&A column, and also room chat on YouTube channel. And it's already one participant who raised hand, to Mr. Julister Sonobe. Good afternoon, Mr. Julister. It's already connected with us. Hello, Mr. Julister. You can ask the question. Hello, Mr. Julister. Well, maybe there is a technical trouble. Now, I would like to read the question from the Q&A column. That's for Dr. Yoga. From Mr. Teguh, the question is, it's possible for us, Indonesian researcher, not just MMIF, to make operational Indonesian ocean modeling like INDESO project or CMEMS. What's your idea about Indonesian ocean modeling? And the second question from our YouTube channel, from Bapak Mr. Bayu Priyono, the question is for Dr. Wei. Are there any impact of Scsb variability in marine resources, such as fisheries? And the third question, it's still from our YouTube channel, from Mr. Bayu Priyono. The question is for Mrs. Asmi. Is possible to predict the anomaly that you explained? Thank you. Yes, for all the speakers, from Mr. Teguh and for Mr. Yoga, time is yours to answer the first question.
Yes, the answer scientifically is possible. Yes, but it's not an easy job to have some oceanographic services like Marine Copernicus or the CCO from the US. It needs a very supporting. I mean, we need some infrastructure first to develop, to build the system, and then we need also the team, many people that is work just dedicated to the services. And then yes, it's possible, and it's also my dreams in the future, if there is some supporting from the top level in the ministry or maybe in Indonesia, that yes, we might have that. Thank you.
Dr. Yoga. Now the second question to Dr. Wei. Time is yours to answer the question. I repeat the question, Dr. Wei.
Yeah. Sorry, I'm not very clear for this question.
Okay, I repeat the question. Are there any impact of Scsb variability in marine resources, such as fisheries? are there any impact of
For the fishery, for the
Are there
fishery,
any fisheries? Are there any impact of Scsb variability in marine resources, such as fisheries?
fishery and migration. Oh, okay. I think it's of course there will be the effect on the fishery migration or something like that. But till now, we have not focused on this kind of infection or something like that. But for in the future, I think we should do this kind of study. As I know that for the MMAF emerald or something like that, there are some scientists study this kind of research. I mean, for the fishery migration or something like that. So I think, based on our future cooperation, maybe we can get the good result, and we can obtain we can get some knowledge about this kind of. But till now, I have no idea for this kind of infection or something like that. Okay, thank you.
Okay, thank you, Dr. Wei. And the third question for Mrs. Napitu.
Thank you, Ulan. I think Bayu asked me, can we predict that anomaly? Is that true?
Yes.
Yes, okay. So Bayu, what happened in 2016 is actually a surprise, is really big surprise for oceanographer community. If you remember, I think you didn't join us during the 2017 cruise, right? I remember Om Yoga was there. So when we retrieve the data from our mooring, we kind of like see the data and it's kind of like, whoa, what is this? We kind of like ask ourselves. So Professor Gordon is actually, he was there, and his habits is actually like see the data fresh from the instrument, and then we see the data. And it's kind of like, whoa, what is this? We kind of like, is this real one? And then actually, from my presentation today, we know that it's real because it's not only happened in our ITF data. This also happened in a lot of instruments. So the model, to answer your question, the model actually could simulate the heat. So remember, I say that there is a heat buildup in Indian Ocean due to the ITF, because the ITF increased during 2003 to 2014. So we built up heat in Indian Ocean. So if the model could simulate the heat buildup due to the ITF and Kelvin wave really well, I think, in my opinion, we can predict that anomaly. But the most difficult part is for the MGO is to correctly model the MGO over the maritime continent. It's really, really hard to predict, to model the MGO to the model MGO right now. That's why we're going to have the project. What we call Year of Maritime Continent, because we need more data to understand, to improve our understanding about how the behavior of the MGO navigates the maritime continents, because the MGO has a unique characteristic. When the MGO starts from Indian Ocean and then it enters Indian Ocean, there is a behavior that is actually changed. And scientists still doesn't understand why is that. Is that because of our topography? Is that because of our ocean condition? Something like that. So if you ask me about how to predict the anomaly, the NGO still really model it right now. I hope in the next future, if we get more data, we can predict it. But for the IOD negative, we suppose, in my opinion, we probably we can predict it because actually ITF give us hint. The ITF increased during 2003 to 2014, and it's build up heat, and that's like the source of the one of the source to trigger the strong, very strong negative IOD during a summertime. I think that is my answer to that.
Thank you, Mrs. Asmi, for the question. And for all the participants, you also can ask the question in Bahasa Indonesia. Well, for the next section, we also have the question for Dr. Yoga. Yes. Thank you.
Can I have a question, Ibu Wulan?
Pardon me?
Can I have question to?
Okay, yes, please.
Yes, okay. So, hi, Dr. Wei. So I have a question. You have a great presentation. So I'm just gonna see my note here. So what's the cause of the decreasing trend in Karimata Strait transport? Because from the ITF through Makassar Strait, so that we have an increasing trend between 2003 and 2014. Why it's different? And then the second one is the transport of the Karimata Strait function of the bifurcation latitude of the north equatorial of the Philippine coast, north equatorial current? I think that's it. Thank you so much in advance, Dr. Wei.
Okay,
Yes,
thank
Dr.
you, Dr. Asmi. For the first question, I think the cross-equatorial flow maybe it's a reason or something like that. And for the second one is you mean for the east Philippines? The second question.
Oh, the second question is the transport of the Karimata Strait function of the bifurcation latitude of the north equatorial of the Philippine coastline?
Oh, I think the main path is the west part of the South China Sea. I think it is for the I think maybe you mean for the Mindoro Strait. I think the transport is not very small, but till now we have not observed this kind of transport. I think the Mindoro Strait is a very important strait for the South China Sea branch, but we will maybe in the not maybe we should do this kind of observation. Okay, but in the future, but we should do the cooperation together with Philippine scientists. It's okay. So maybe we can look for this kind of.
Thank you, Dr. Wei, for the answer. Mrs. Asmi?
Yes.
That's enough?
Oh, of course.
Oh, yes.
Of course.
Yes. Okay, we will move to the next section. We have a question for Dr. Yoga. In your slide, you mentioned that by using ocean numerical model, we can have better fishing zone prediction. Could you please explain how to realize this in support the improvement of IMRO fishing zone prediction? Example, model that satisfy for specific region and specific fish species with high accuracy. And the next question is for Mrs. Asmi again. At this time, do we have a center data for Indonesian ocean modeling which we can download freely? If not, what would be the obstacle? Well, please answer the question to Dr. Yoga. Time is yours.
Okay, very nice question. Can you see me? Okay. Yes, actually, the some methods that I know that how to make a prediction in the for the fishing zone is by using the SST data and then the surface chlorophyll data. And yes, because the limitation of the satellite data because of the cloud cover, and then there is no prediction of the satellite data cannot make a predictions. But in using the numerical model, for example, we can have we can have an opportunity to have better resolutions, and then in order to simulate, and in order to what we call in order to make predictions in the sea surface temperature, for example. And why is it possible or not by using the numerical data? The key is the atmospheric input for the ocean numerical models, and the atmospheric input, the solar penetration, and then the humidity, and then the precipitations. It will be of key important to the numerical model to calculate the dynamics of the surface. And because actually in developing the ocean numerical models that can be used as a prediction to the potential fishing grounds, the ocean numerical model just provide the data, and how the data can be used as the calculation or as the prediction to specific species. And it is actually it is not my field of expertise. Maybe it will be maybe the biologists or maybe the researcher in the fisheries can use the data. Actually, just what I want to propose, what I want to just to provoke to the scientific community in Indonesia is that if we can have a good input data for the ocean numerical models, the good atmospheric data, a good parameterization in the mixing, in conjunction with a good assimilation, with the observation, with the many real-time data, it will be very logic. The numerical ocean model can give an output more realistic and maybe more closer to the observation from the satellite. And it's still under development because we still now for the oceanographic data, we just until now we can download the data from the internet, and some of the producers, some of the institute that provide the data, for example, the Marine Copernicus, and maybe in the next year that it's not free anymore, and then from the service from the US, the ECCO consortium, maybe it's not free. So it will be a challenge for us. It will be very difficult for the colleagues that working in the ocean in the potential fishing zone to get the data in order to make a good prediction in the potential fishing zone. But also the model is also to have a limitation. If we want to have a very fine resolution, for example, less than 1 kilometer in Indonesian seas, we need a very huge computation infrastructure. We need a lot of computational times and also a lot of effort to do the post-processing of the data. Maybe it's just 3 kilometers. I think it's enough just to make a better resolution in the near coast, just to produce the data for the people who wants to make a prediction in the fisheries. And one thing, the last thing is the model is also can be coupled with the biogeochemical models. So the biogeochemical maybe can provide the data if there are some if the data for the chlorophyll, for the kesuburan perairan. I forgot the nutrients in the oceans. It will be another data for the colleagues in the fishery sector, for the researcher in the fisheries, how to make the better predictions for the fishing zone. Okay, thank you.
Thank you, Dr. Duyoga. The next question for Mrs. Asmi.
Thank you, Wulan. So I think the question is, do we have a center data for Indonesian ocean modeling, right?
Yes,
so
right.
This question is best if we ask Om Yoga and Uni Desi, but probably try a little bit. So do we have the center data for Indonesian ocean modeling that we can download? If you refer to Indonesian ocean modeling that is originally built up in Indonesia, I don't think we have it yet, but I think that's one of the goal, one of the dream of the Indonesian, the IMRO. So we hope that in the near future, our researcher in IMRO will start to develop original model that we build up by a collaboration with all modeling in Indonesia. So as right now, I think that we usually download Indonesian model for Indonesian seas from free website from United States, from French, from a lot of institution abroad. So, but if you ask, just going to twist a little bit, if you ask, do we have a center data for Indonesian observation data? Also, I think that is you can download freely. Also, I think that the answer not quite yet true, but I hope again the Institute Marine Research for Observation can work as a leader to develop this kind of center, so we can put all the data in our system, and then after we make sure that the data that we have is good enough, now everybody can share it. Right now, I think the IMRO, I think Desi provide slide about the data that IMRO have, but it would be beautiful if all the data that we have right now, we can put it in one institution so everybody can download it. I think Yoga can answer the question. I think it's from Mbak Niken, whether we have a center data for Indonesian ocean modeling or not.
Yes, Mr. Yoga. Any additional answer for the question?
Yes, I'm still thinking, but as far as I know, we don't have any center to download the data, just like Marine Copernicus or the services from the United States or from Japan. I don't think so. I don't find any sophisticated website in Indonesia that you can download. Actually, during the Indonesia projects until 2017, you can just enter the websites and then you can download many oceanographic data. But now, maybe the BMKG, the Agency for Meteorology, maybe you can download the data because they have also the services for the ocean prediction, I think, in their website, and also from the BIG, the Agency for Geospatial, they have also the website for the operational ocean model, but I don't know. I never used their data, and I don't know how to download the data. Maybe by sending a letter to them, you can download freely, maybe.
Mas Yoga, but do we have a Indonesia model for Indonesian seas that's actually built by Indonesian scientists?
In progress.
in progress, right? That's
Because
what,
I'm working now with
So-
colleagues, and then we just installed some configuration in Indonesian model. We make some tests. I made some tests in their machine, because I don't have any we don't have any computers in the in the Marine Research Center, neither in IMRO and how to use the model. The only good infrastructure is in BMKG or in LAPAN or in BIG, the Indonesian Geospatial Agency. So that's why I try to make a collaboration with them, and then we try to make some configuration, 136 the configuration in Indonesian seas, and I don't know, it's still just a beginning, and then we still, we still in PDKT, you know, in what is just in the very beginning step, and then maybe I will talk to Pak Nyoman next week after I finish my survey here in Bali, and then how to make a collaboration with other institutions, because it's very hard to do the modeling in our center in Jakarta, and then, as well as in Bali. Okay.
Mas Yoga, saya tunggu di kantor ya.
Ya, siap Pak. Okay.
Thank you, Dr. Duyoga. And the last section is the last question from Mr. Romi for Mrs. Asmi. The question is, I found the paper about Indonesian truck flow as a preconditioning mechanism for submarine landslide in the Makassar Strait. How ITF is correlated with submarine landslide? To Dr. Asmi, time is yours.
Thank you so much, but I read that, but I don't really quite understand it. So unfortunately, I think I cannot answer that question. So because that's I read that. So how the ITF related to the landslide? I'm sorry, I cannot answer your question.
Okay, it's okay, Mrs. Asmi. Thank you, and for all the participants, because of the limited time, the discussion section is over, and now we move to the next agenda. Our moderator, Mrs. Desi Berlianti, will share the conclusion of this webinar. To Dr. Desi Berlianti, time is yours.
All right, before we close, let's review what we discussed. Indonesia is vulnerable to IUU fishing, climate change, anthropogenic impacts, so the ocean observation system is crucial. The ocean monitoring and information system is a way to address the issue. Therefore, some collaboration are needed to utilize the combination the field and space observation and numerical techniques, for example, for assimilation and to fill missing parameterization scheme. Other point is the observing system could be used to understand the phenomenon starting from global into detail, but it needs to be applied sooner for the beneficial of marine resources management. So that's all for our review for today's webinar. And I'd like to close this session by thanking all to the speakers and for their participation in our webinar. I would also like to thank the team behind the scene for serving today's webinar this afternoon. It was a pleasure to have you with us. Well, ladies and gentlemen, that wrap up our afternoon. I thank you all for your participation and joining us today. Hopefully, we have learned from the presentation and discussions. We wish that all discussion would be fruitful and benefit to all aspects and everyone. finally, it's been our pleasure as your moderator on this webinar. Apologize for any circumstances, and I wish you all a pleasant day. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Desi. Well, ladies and gentlemen, this is the end of this webinar. And now our team will share the link of the materials and also link of electronic certificate. The link is only open only 10 minutes, and all of the participants can write down the name and the institution. Well, thank you for all the speakers, and also thank you for Mr. Dr. Inyoman Radiarta who joined this webinar until the end. And I will inform all the participants that the electronic certificate will be, we will share the electronic certificate 2 weeks after this webinar ends. And I will inform you that don't follow to like and subscribe our YouTube channel at Bepol KKP and our social media, Instagram and Facebook at Bepol KKP, also on our Twitter at @riset_prancak. Yes, thank you all for the join with us and see you on the next webinar. Me Komangulan and team sign out. Wassalamualaikum warahmatullahi wabarakatuh. Om Santi 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 Om. Have a nice day.
Thank you, Dr. Jason.
Thank you, everybody. Bye.
Thank you, everybody. See you next time. See you next time. Okay. Newman. See you later.
See you later.
Okay. Semi. Okay.
Terima kasih Pak Nyoman.
Yuk sama-sama. Ditunggu di Indonesia secepatnya.
Ya Pak.
Bali. The Marine Research and Observation Center is located in Prancak, Jembrana, Bali, the strategic location in the central Indonesia that has the most marine resources has made the research center a marine center of excellence in Indonesia. The research center seeks to innovate and conduct strategic research to support the development of marine and fisheries human resources. Innovation is an important key for the research center, which is supported by professional staffs as well as essential research infrastructures. The infrastructures are available in the research center include the Bali Earth Station, a satellite radar, a marine research laboratory that comprises a marine quality laboratory, marine remote sensing laboratory, and marine observation and modeling laboratory. The research center, researchers and observations have resulted in various valuable products such as the marine prediction system known as the SIDIC. The SIDIC is an information system that presents online data and information such as the fishing zone prediction map, the national map, the fishing port map, the special water maps, tidal information, coastal oceanographic information, satellite imageries, field measurement data, oceanographic model data, information on monitoring of coral reef ecosystem, water quality of Prancak estuary, as well as information on mangrove ecosystem. The Research Center has also innovated in the production of environmentally friendly artificial reefs known as the BioReef Tag, coastal buoys that provide information to support the system of oceanography and archipelagic marine application. In addition, the Research Center has actively participated in the activities of the Southeast Asia Center of Ocean Research and Monitoring. Through continuous researches using marine observation technology, marine remote sensing and modeling, the Research Center remains committed in providing data and information that are crucial to support the establishment of marine prediction system that will benefit the community.
Balai Riset dan Observasi Laut atau BROL mempersembahkan SIDIC, Sistem Prediksi Kelautan. SIDIC dirancang sejalan dengan pembinaan BROL sebagai pusat unggulan iptek Sistem Prediksi Kelautan. Agar Agar dapat mengakses sidik, pengguna harus melakukan registrasi secara online terlebih dahulu untuk mendapatkan hak akses data dan informasi di dalam sidik berupa data citra satelit, data model oceanografi, data pengukuran lapangan, informasi peta perakiraan daerah penangkapan ikan atau PPDPI, informasi peta lokasi penangkapan ikan atau pelikan, informasi prediksi pasang surut, informasi oceanografi pantai, informasi status mutu estuari perancak, informasi ekosistem terumbu karang, dan informasi ekosistem mangrove.
Bali. The Marine Research and Observation Center is located in Perancak, Jemberana, Bali, the strategic location in the central Indonesia that has the most marine resources has made the research center